Now let's look at framing and flow control. Fibre channel is essentially a layer 2 frame-based protocol. So let's find out what a fibre channel frame looks like. Firstly, fibre channel frames can be up to 2,148 bytes in length, with framing overhead consuming a miserly 36 bytes, meaning the payload of a fibre channel frame can be up to 2,112 bytes. At the front of the frame we've got the start of frame delimiter, the SOF. It's 4 bytes in length and it tells us things like the class of service in use. Next up is the frame header. This is a little longer at 24 bytes and it contains the source ID and destination ID which are used for frame routing. Source ID or SID and destination ID or DID are the endport IDs of the source and destination. So that's the endport ID of the host HPA and the endport ID of the storage array port. Then comes the payload, which is the meat of the frame. This is where the actual SCSI data is encapsulated. And after all, Fibre Channel Protocol is all about encapsulating SCSI commands and SCSI data within a lightweight networkable frame. Following the payload area is a 4-byte cyclical redundancy check, a CRC, which is used for frame integrity. And last of all, we finish off with a 4-byte frame delimiter. All in all, up to 2,148 bytes, with only 36 bytes or 1.6% lost for framing overhead, making Fibre Channel Protocol very lightweight and very efficient. Now for some flow control basics. At the lowest levels, Fibre Channel SANs work with frames. Frames are then grouped into sequences. And finally, sequences are grouped into exchanges. These are the three constructs that form the basis of communications on a Fibre Channel SAN, and a good way to conceptualize where each of them fits is to think of frames as words, sequences as sentences, and exchanges as conversations. Okay, over and above what we've just mentioned, there are two credit systems used for flow control: end-to-end credits and buffer-to-buffer credits. First on the menu, buffer-to-buffer credits, or sometimes called buffer-to-buffer flow control. This is the flow control scheme that you'll need to understand the best because it's used by Class 3 traffic. And if we remember back, Class 3 traffic is by far and away the most popular type of traffic. Buffer-to-buffer credits work between N ports and F ports, so between host HBA and switch port, or between storage array port and switch port. Now when an N port logs into the fabric, it's issued with a pool of credits and is allowed to transmit one frame for every credit that it has in its pool. And for each frame that it transmits, the N port must deplete its pool of credits by 1. So, for example, if an N port is issued with 5 credits, it can send 5 frames. Once it's sent 5 frames, it can't send any more until it's issued with more credits. It's a pretty simple system. No credits, no frame sending. The N port's pool of credits is replenished by the F port that it's connected to. How this works is, if the F port, the switch port, is ready to receive more frames, it will issue receiver ready frames to the N port, and the N port increments the number of credits in its pool by 1 for every receiver ready frame it receives from the switch. This way, if the switch is temporarily unavailable to receive more frames, it just won't issue receiver readies to the N port, effectively forcing the N port to cease sending frames until the switch is ready. Really simple, but importantly, really effective at avoiding congestion and frame dropping. End-to-end frame control, or end-to-end credits, is similar but slightly different. First up, it's used by Class of Service 2, so it's nowhere near as popular as buffer-to-buffer credits. And as the name suggests, it's an end-to-end system, meaning that credits are established and exchanged between endpoints in the connection, N-port to N-port, such as Node HBA port and Storage Array port. This has got nothing to do with switch ports this time. And as with buffer-to-buffer credits, an initial pool of credits has to be established so that a device can start sending frames. But whereas buffer-to-buffer credits are initially established as part of the fabric login process, the initial pool of credits in the end-to-end credit system are established during port login, or PLOGI. That is, one N port logging into another N port. And because Class 2 traffic is based on acknowledgements, The ACK frames or acknowledgements are used to replenish credits. So, as an endport sends a frame, it depletes its credit pool by 1, and upon receipt of an ACK frame, it replenishes its credit pool by 1. It's as simple as that. Now, let's take a look at NPIV, Endport ID Virtualization.